This tutorial describes how to use recursion to solve for a specific term within the Fibonacci sequence. The first two terms of the Fibonacci sequence are defined as 1. To find the third term in a sequence, you must add together terms 1 and 2. To find the fourth term, you must add together terms 2 and 3. The pattern continues in this way. A specific term in a sequence is defined by adding the two previous terms together. Here we demonstrate how to use recursion to solve any given term in a Fibonacci sequence. Define the function with an output, function name, and input. Define terminating conditions. If n equals 1 or n equals 2, then the output equals 1. If the terminating condition is not satisfied, then proceed to the next operation. The answer equals fib n-1 plus fib n-2, which represents the sum of the previous two terms. The function ends. Next, we will describe why the function calls itself through recursion. Call the function with an input n. Check the terminating conditions. If the terminating condition is not satisfied, calculate the answer using fib n-1 plus fib n-2. Notice that fib n-1 and fib n-2 call the function fib twice with inputs n-1 and n-2. Check the terminating conditions. If the terminating condition is not satisfied, calculate the answer using the two function calls once again. The recursion will continue until terminating conditions are reached. Next, we describe how the function calls itself. Call the function fib with input 5. Neither of the terminating conditions are satisfied, so we must use recursion to find the answer. To begin, fib 5 equals fib 5 minus 1 plus fib 5 minus 2. Next, we will address fib 4 equals fib 4 minus 1 plus fib 4 minus 2. To compute fib 4, we must define fib 3. Fib 3 equals fib 3 minus 1 plus fib 3 minus 2. Fib 2 equals 1 because it satisfies the terminating condition. Fib 1 equals 1 because it satisfies the terminating condition. This makes fib 3 equal to 1 plus 1, which equals 2. This is used to define fib 4. Fib 2 equals 1 because it satisfies the terminating condition. This makes fib 4 equal to 2 plus 1, which equals 3. This is used to define fib 5. Notice that fib 5 minus 2, or feb 3, must still be defined. As demonstrated earlier, feb 3 equals feb 2 plus feb 1. These are both terminating conditions with each equal to 1, resulting in feb 3 as 2. This makes feb 5 equal to 3 plus 2, which equals 5. This ends the recursion process and returns the fifth term in a Fibonacci sequence. Thank you for using MATLAB Marina for your programming needs.